So,
Thanks, Dinesh.
yeah, thank you. So our next speaker is Mr. Saurabh Purandare. Saurabh sir, he is from Team Innovella, Building Solutions as a director. So I would request Saurabh sir to come on the dais. So Saurabh sir is ME Structural Engineering from Maharaja Shivaji Rao University, Baroda, and B Civil Engineering from MIT Pune University. And he has a work experience in the segment of precast concrete construction of more than 25 years, including 4 years overseas experience also. Being a structural engineering professional with international exposure in performing structural design of residential, commercial, industrial, utility structures and more, he was among the first people who introduced precast concrete construction in India. He is their team is the main goal of their team is to gain stronger technical knowledge and continue the excellence in providing structural engineering services, advanced technology, innovative concepts, and effective quality management systems. So they are working to provide innovative and creative solutions using precast concrete technology in Indian construction projects. So Saurabh sir is here and today he will be talking about importance of cost-effective designs standardization in large-scale precast projects. Sir, we can have you here.
Uh, Hello, fellow engineers and friends. My name is Saurabh. I'm from Innovella Building Solutions Private Limited. I'll be speaking about standardization or importance of standardization in large-scale precast projects and overall, situation of precast concrete technology in general in India so far, and what is the way forward, and what are the new projects we are working in, and what is the new trend that we see coming up in precast concrete technology itself. So let us discuss about the current situation of precast concrete technology in India. Uh, Amit also spoke about it. Mr. Dinesh Kumar also spoke about it. The concrete technology is being used in India majorly by private players in non-governmental, residential and commercial building projects for last decade or so, since 2010. So 2010, our major first project was Pragati Towers, which was shown by Amit. And since then, we have worked on various other projects also. What has happened is, all these projects that we have done so far, majorly, they have been constructed using one-dimensional elements like column beams or two-dimensional elements like floors, slabs, and walls. That is the major stuff which is currently ongoing in Indian precast industry. Again, if we look at this past decade, we have constructed almost like 100 million square feet. Now, this is very approximate ballpark figure that I'm talking about. This is just my guess because in our office we have done almost like 40 million square feet of precast construction which is completed so far. So I'm assuming everything put together is round about 100 or maybe more than that also slightly. But look at that, from the point of view of total Indian construction industry, and it is not even 1%. I'm on the safer side, I'm saying 2% actually. So that is the current status. And everybody talks about precast concrete technology having a great advantage in terms of time saving, reduction in labor force, and that labor force reduction is such an advantage, particularly post corona situation. How you are dealing with, how you are going to deal with the projects which requires very huge amount of labor force. I mean, that is just not on as far as no, next future is concerned. Again, we are talking about better quality construction, but precast concrete technology is not amongst the first choices, so far. And why so? So just looking back at why it is like that. So this is based on my experience, and general everybody's experience is more or less same. So what is the hesitation from client side to adopt precast concrete technology? First is high indirect cost. The initial investment and the plant maintenance cost is very high, which is almost 100 to 150 rupees per square feet. If you want to implement precast concrete technology in a project, the viability becomes very marginal. That means you must have a project where the speed requirement is roughly 1 million square feet or 10 lakh square feet per annum to 40 lakh square feet or 4 million square feet per annum, and going on for a period of, let us say, at least 3 or 4 years, so that your initial plant cost or plant investment is returned back to you, and then that is giving you the viability. So it's a very limited kind of a project that falls into those categories. There are, at least 80% of the projects will not fall in this category between 1 million to 4 million speed. uh, 10 to 20% higher cost of construction and so on. I mean, that is what it is. Uh, but again, there are reasons for it. And I'm trying to understand the reason why the overall cost of construction is high and where we can, reduce this increase in the construction cost. So first is expensive connections. So connection is expensive. See, your concrete is concrete, your reinforcement is reinforcement. If concrete costs X amount per cubic meter, it costs the same X amount for precast concrete also. It doesn't matter. Reinforcement costs same. Where the actual cost increase is happening, that is happening in the connections. Because connections involve very expensive materials, like special grouts, which are generally, 50,000 rupees per cubic meter or so. Sealants, PU sealants also, which are generally in the region of 500 rupees to 1,000 rupees per linear meter kind of a cost. Special hardware requirement to connect the two elements together in terms of maybe loops or maybe, some other stuff, couplers. There are so many other things which are coming into picture, which is a very special hardware, which is increasing the cost, overall cost of the structure. High erection cost, and that is because of the higher number of elements to be erected, because when we see an apartment size, let us say affordable housing, 300, 400 square feet of apartment. For building one apartment, you need about 20 to 25 elements to build one apartment. So, the more the number, the more the erection cost, obviously. The transportation cost is very high. If it is, like out of site kind of or dedicated plant, which is not on site, it's off site construction. Then third point is the concerns of industry professionals, specifically with respect to leakages, because that is where, people have a lot of fear. Uh, that is misplaced to some extent, but not to 100%. Of course, there needs to be a concern about that. Uh, and because particularly the life of PU sealant is almost 5 to 10 years. That means you have to redo your sealants. So one way is to avoid sealants altogether by detailing the joints properly, or to reduce the number of joints so that, that maintenance becomes easier. And the second point is lack of ductility from structural behavior point of view, because it is a non-monolithic structure. The connection is involved. There is the connection, even though we do a emulative design or whatever it is, the monolithicity of the structure is, hampered to some degree. So ductility is reduced to some extent. Again, the conventional precast system, which is 2D precast system that we are talking about, needs elaborate temporary supports and scaffold system also. For example, if you want to erect 2D walls, you first have to have, your temporary props, and then you can disengage your crane. That prop has to remain in position till your slab is in position, then the screed is done. And once that screed achieves certain strength, then you remove those props, take it to the next level. So we are not reducing very large amount of site labor or site works. But yes, of course, we are doing that. But again, these are small things which are still happening, or those are still required. Again, laborious finishing works even after the structure is completed. And lack of standardization in architectural design, everybody actually mentioned it. Every project that we have worked on so far, the architecturally it was designed for commercial, for conventional system, like cast in situ construction or whatever. Now, to force or enforce your precast concrete technology in such kind of a structure is a challenge, and that is where the problem also lies. So there are a lot of avenues where architectural designs can be improved to suit precast concrete technology. And if client decides early, at an early stage to adopt precast concrete technology as a strategy, then the structure, the architectural design can be developed keeping the precast concrete technology in mind by having standardization in architectural design. So what is the benefit of standardization that we are looking at? Because of the optimum mold utilization, the reduction in capital investment will happen. That is only going to happen because of the standardization. If I have 20 different elements to manufacture in a single apartment, then my cost of molds is going to be higher. But if I'm going to do that using only 7 or 8 standard elements, then of course my initial investment comes down. The increase in project viability increases because of the lesser indirect cost, and the automation process can be implemented on such kind of standardized units based on the efficiency requirement. What is the speed requirement? So to that degree, we can automate the processes. Of course, there is economy of scale which is involved once the standardization comes into picture. And the last point, which is very important and which is what is needs that everybody needs to strive to go for. We need to have precast products selling out of shelf, from the main contractor buying the stuff from the precast suppliers and implementing or erecting on their projects. That is what happens in Europe. The project is never awarded to precast concrete or precast manufacturer. The project is awarded to the main contractor. The main contractor's subcontractor is a precast manufacturer. He buys the elements from the precast manufacturer and erects it himself. So precasters, role is only to manufacture the element and transport it to the site. And that is where the major possibility of what Amit's dream is, of having a centralized plant will come into picture or come true. So trying to do that. So introduction to out-of-box construction. So we are talking about something based on our last more than, this kind of concept is there in our mind since last more than 3-4 years. So initial 6-7 years, we realized all these shortcomings in precast concrete technology. And we said we need to improve it for India, because the same technology which has been implemented in Europe, in USA, in Far East countries like Singapore or maybe the Gulf countries may not work in India because India is a different culture. India has a different kind of living habits for the people. So we need a solution which is India-centric solution. So that is where we developed this as a out-of-box construction approach. That is what we are calling it as. And the aim of this construction approach is to achieve high degree of standardization at the time of concept design itself. And second is reducing the overall number of precast elements required per apartment, thereby reducing the cost of logistics considerably. Now, when we look at any residential apartment, what happens is kitchen and toilet. Those are the areas which can be very, very easily standardized. Nobody's fussy about what is my kitchen size and nobody's fussy about what is my toilet size. They're more worried about living rooms, bedrooms, and those kind of things. So for example, for 1 BHK apartment, we say 2.4 by 2.4 as my kitchen, and maybe 2.4 by 2.4 consisting of 2 toilets as my toilet block. And maybe we can use this same again for 1 BHK as well as 1.5 BHK also. Or maybe we can have a different thing. So we can have these modular kitchens and modular toilets in terms of sizes only. Even I'm not talking about door positions, window positions, ventilator positions, nothing. Only sizes. If we can modularize the size of the kitchen and size of the toilet, lot of things or lot of wonders can happen with precast concrete technology. So what we are trying to do is we want to do the standardization in kitchen and toilets and manufacture it as a 3D box with 4 walls and base slab. And these kitchens and these toilets can be pre-finished in the yard itself, with all the finishes in position, So it's kind of a plug and play kind of kitchen and plug and play kind of toilet, which is erected on the site and it starts working. And mind you, these kitchens and these toilets, we are calling it as 3D boxes. Those are load-bearing 3D boxes. These are not non-load-bearing 3D boxes. So this boxes becomes part and parcel of the main structure. And actually, these boxes actually becomes major part of lateral load resisting system as well as vertical load resisting system. What are the benefits of such kind of construction? One is lower indirect cost, because now, for example, we are doing currently two, projects using this concept. And we find out that instead of 20 elements, I can do the same apartment in 12 elements. That means I am reducing almost, 40% of my number of elements. So my 40% of crane sizes have been reduced. Even though the cranes capacity requirement has gone up, but my number of cranes have reduced considerably. My stockyard becomes suitable. All my logistics becomes more, easy. It also improves my viability for smaller projects as well as for mega projects. For example, I'm going to showcase to you the case studies in next slides for two different projects. One project is 1,000 apartments to be built with a speed of, in 1 year's time. So you can say 3 apartments or 4 apartments per day. The other project that we are doing is 1 lakh apartment, smart city housing, and we need to build 80 apartments per day. So from 4 apartments per day to 80 apartments per day, but the concept that we are using is same. So that kind of scalability that we are looking at. Again, coming back to 2D precast construction, for 80 apartments to be performed per day, 2D precast technology is not viable. Please understand, 20 elements every day multiplied by 80. Those many elements to be produced every day, handled every day, transported every day, and erected every day. That is impossible. So that means for such kind of projects, you need something very, very special uh, in terms of standardization so that you can reduce the logistics requirements drastically. And that is what exactly we try to do. Improved structural behavior, basically because of these boxes. For one room, generally we have 4 vertical joints and 8 horizontal joints, 4 at top floor level, 4 at bottom floor level. So we are talking about 12 number of joints. So here 8 joints are monolithically cast and only 4 joints are to be dealt with. That means we have reduced the number of joints to almost 67% in the entire project. That is what actually is going to reduce my cost of that expensive grout material, expensive spatial hardware, and so many other things. Because of my reduction in number of elements, my erection cost has reduced because my number of crane requirement has come down to almost 40%. Reduction in transportation cost because my trailer is getting utilized in an optimum way when I'm transporting my elements. Uh, Temporary supports and scaffolding, at least for these kitchen units and these toilets units, is gone away because these boxes are stable of their own. After erection, they don't need any temporary propping or temporary supports. It saves lead and lift time of the finishing material because finishing is happening in the yard. That means finishing doesn't have to be taken at the floor level, and the labor also doesn't have to go there to finish kitchens and toilets. And mind you, kitchen and toilets form almost 90% of finishing work in your entire building. So 90% of your finishing work is taken care of at the factory level itself. Uh, so it saves your overall construction time. So it's not only the construction of the structure time which is saved, but finishing time is also saved in the process. So if you compare it with 2D precast, it saves you 25% of the time. And of course, better QA QC for the finishes. Can we take next slide, please? Yeah. So that's the typical connection that we are talking about because the pods are manufactured with base slab and there is a peculiar challenge of erecting such kind of pods uh, at a higher level. That is what we faced in L&T first project, Boivada. We used this kind of a system or a very similar kind of this system where we use WC and bathroom, very small units, 1.2 meter by 1.2 meter or so, 7-ton element, which was not pre-finished also because of some other reasons, because excise duty was, there at that time. So it was better that we didn't finish that. But now with GST coming into picture is ballpark for everybody. But what we found out that the erection of such pods becomes very difficult because the erection of the pods has to happen, and then the remaining structure comes around it. So we have improvised it in terms that on top of the wall of that pod, we have a corbel kind of a situation where you first put your slab on the lower pod. And once that access is there, then you erect the next pod and screening happens afterwards on top of the hollow slab. That is how we have, erection point of view, we have taken care of this. And again, when it comes as an external joint, we are actually projecting out our base slab. So it actually hides my horizontal joint, which is going to happen. And I'm totally avoiding my horizontal sealant requirement altogether. So that is what my saving my cost also, and maintenance point of view, I'm not worried also. Yeah, now we are going with the case study. So this is the kind of apartment plan that has been developed. Actually, this is the project where we need to do 80 apartments per day. So we were not really bothered about the element weight as such, but we wanted to really cut down on the number of elements drastically. So what we did, we actually did kitchen plus toilet as one single unit. That's the L-shaped pod that you look at. And then the bedroom and living room is, formed in conjunction with that. But my main load-bearing element is kitchen and toilet unit, which is cast as 3D element, which is a standard modular 3D element. This is the typical building plan. You can go to next slide. Structural framing plan. And this is how the manufacturing of the pod is happening. And such 80 pods we are going to manufacture every day. Once our state-of-the-art plant is going to be in position, maybe it will happen in next 6 months' time. And we are having a lot of automated systems in order to achieve these kind of things. Steam curing is the most important aspect of all those things. And it's a carousel system with which all these things will be manufactured. Base slab actually helps in doing that as a carousel. So all those things we are doing. There's kind of an animation which goes. So even the lifts that you see over there, those are also made modular. So we are trying to make as many, modules as possible so that we can reduce the number of elements to as high degree as possible. We can go to the next slide. The another project, which is 1,000 apartments project. This is lighthousing project at Ranchi, driven by central government. There are 6 technologies which have been shortlisted. 3D precast technology is one of them. Now, if you go to the previous slide, you look at that kitchen and bathroom. So what we are trying to do over here, because these are only 1,000 kind of apartments, we wanted to create one single mold which can manufacture kitchen as well as toilet. So my kitchen is same size 2.4 by 2.4, and the bath WC and the passage that you see, that is also again the same size 2.4 by 2.4. So I'm having only one typology of mold which can produce both these elements, kitchens as well as toilets. We can go to the next slide. And these becomes then my main load bearing elements. My next slide, please. Yeah. So my slab actually spans from kitchen pod to kitchen pod in horizontal direction also and vertical direction also. My toilet pod is there as a main lateral stability element. And over here also again what I'm trying to do is we are trying to do it the slabs as pre-stress solid slabs, and we are manufacturing or we have manufactured molds to produce these standard solid slabs, pre-stressed solid slabs. So these are self-stressing molds which we have designed so to make it portable, basically, to move it from one plant to another. We can go to the next slide, and these are the two kitchens and toilet kind of an unit. The T-shape partition wall that you saw over there, that will be inserted at the time of finishing afterwards. That is 75 thick. So here we also actually tried to do is we have T-shaped walls. We have passage slab which is kind of a bridge element, C-shape beam with parapet wall with connecting passage slab. If you go to the toilet unit, you see that bottom slab projecting out. So that bottom slab is projecting out for half of the passage width. So half of the passage slab is also formed along with that toilet pod itself. So here what our aim was, because this pod is going to have some kind of a 12-ton weight, so we wanted to have as many elements near to 12 ton as possible, so that we reduce the number of elements and we optimally utilize our cranes. And in this situation, actually what has happened is we have improved on the numbers, even though our are 2 in numbers, but other elements we have reduced and we have matched them with the weight of the pod itself. Thank you.
Should we take questions from audience?
I'm also working as a waterproofing consultant. So my question is regarding waterproofing only. In your slide, it has been said that is 15 to 20% rise is only because of the cost of waterproofing, maybe. So if by any method, if that cost has been reduced, can it be affordable construction for a housing?
Waterproofing is one of the reasons. The other reasons are also equally important, like high indirect cost, and then there is a logistic which comes into picture. And waterproofing cost can be avoided altogether. Like we have done that, or we are doing that in our one of the project, which is Project Seabird at Karwar, which is very high intensity rainfall area. And what we have done is we have detailed the joints in such a way that sealants are not at all required. But nonetheless, what happens is with those kind of joints, or detailing, your 2D elements also become kind of very fancy elements with nibs and those kind of things, which increases your mold cost, or which increases your other costs. So what happens overall is, you have got rid of sealant not from the cost point of view. We wanted to get rid of sealant because it is something which is to be maintained, and specifically in affordable housing projects, there is a very big question mark whether after every 5 years or 10 years, which is the life of the sealant, whether those can be replaced. So there is different, it's not only the economic reason that we want to not have that sealant, but there are other reasons also apart from that.
My next question is, suppose what I heard or have seen in the your presentation, you have to have something structural screed on your core slab. Suppose if I use that core slab on the top terrace, and if that top terrace is non-accessible, and if I can provide a slope to itself to your precast slab, can we avoid that structural slab or something so that
That
reduce the
structure,
cost?
sorry, sir, but that structural screed more or less is to do with diaphragm action. And, of course, waterproofing is one of the criteria, but major criteria or structural criteria to have that structural screed or structural topping is to have your diaphragm action going, you know, because your precast structure is all jointed structure. And what is binding everything together is going to bind this structural screed, which will be cast on top of these slabs. And that is where, the structural screed plays that important role. For example, right now we are doing one building in Hyderabad, which is a kind of a temporary building, which will be dismantled in next 5 years' time. Over there, we are not using screed, but again, that helps me because Hyderabad being seismic zone 2. But then again, we have to have some kind of a welded or bolted connections between the planks, which makes it very, very difficult, and it becomes then dry jointed structure, more. And such kind of system we are adopting only because we want to remove these slabs, after 4 years or 5 years, and we want to reutilize them maybe or at some other location, afterwards, if it is possible.
Thank you.
Hi. My basic first question is about the construction on using precast in different areas. For example, Amit has shown the project in Bangalore where the complete mass housing project was done. A similar kind of project if done in a seismic zone 4, for example, say Delhi. What is the feasibility of doing precast? Means from efficiency point of view of the joints, what will be the difference as such?
Yeah, so basically, we have done, or others also have done, buildings in seismic zone 4, particularly in Delhi. I've been involved on a project with Supertech, where we had these 3 podiums plus 20 upper floors, which we built using, load-bearing precast walls and hollow core slabs. Of course, there are challenges in terms of designing of those connections, but they can be done. I mean, it's not that it's difficult. Sometimes it becomes cumbersome from practical point of view also, but it can be done. And of course, over there we use 2D system, but once we go with 3D system, for example, currently that Vasai project that I showcased to you, Suraksha Smart City, that is 23-story towers, which we are using, I mean, building using this kind of pods again. And because those are monolithic pods, again, I'm sorted out for 67% of my connections, only 33% of connections, which I can detail properly. And with the, advancement in coupler, kind of a technology, we are also adopting, these Gravtech couplers on most of our projects. And because of that, a lot of things have improved. Uh, the project which I did, with Supertech, which was almost about 7 years ago, 2013, 2014, I think. At that time, those kind of couplers were not really there. So we used couplers over there. We staggered the couplers, but it was quite cumbersome. We had to increase the diameter of the dowel tubes on the alternate dowel bars, and so on and so forth, which again increased my grout quantity and other things. But yes, it can be done, and with proper detailing. And if rather than, I would say, proper detailing, architectural plan actually plays a more important role than anything else in any of the projects. I mean, that is what I have seen so far. I see a lot of buildings, 30-story, 40-story buildings with fan shape and, those fancy shapes. Rather than that, and those buildings are, as it is, going to be expensive in cast in situ also, those becomes expensive in precast also, or becomes cumbersome or not so possible to do in precast in those situations. But if architectural plan is sorted out, then most of the things can be taken care of.
Thank you.
I presume that all of the precast construction you have talked about is above the plinth level. What about the foundation and work up to plinth level?
Generally, in any project, foundation and substructure, that is what we are talking about, is cast in situ construction. It also helps in terms of logistics, because by the time your foundation and substructure work is going on, you set up your precast plant, and you start producing the plant once, just in time kind of a basis. That helps in that way. And also, precast concrete technology advantage can be leveraged once we have standard elements. And those standard elements are possible only in superstructure. For example, if we have 10-story building and 4 apartments per floor, that means we have 40 repetitions for one building, so as to say. And that kind of repetition is not available in substructure. So that doesn't become cost effective. Uh, and generally, that is why conventional system is adopted up to plinth level, and precast structure is generally in superstructure.
So, as I heard that you are a student of MIT Pune, I'm also pursuing my post graduation in MIT WPO now. Sir, my question is regarding connection details. I wanted to ask that are there any connection problems while doing precast construction, and if there are, how can we deal with it?
The connections have to be designed for the forces. That is as simple as that. So basically, it's a cumulative design approach. That means you, even though the building is designed as a precast building, it is considered from performance point of view as a monolithic building or equal level of performance. And then you find out the forces in the connections and you design the connections according to those forces. And the major thing for to look after connection design is your parent element can fail, but your connection should not fail. Again, that is the major governing principle. So that should not be your weakest link in the structure, so as to say. But again, there are so many other aspects as far as connections are concerned. The practicability of it, the skill set of the laborers. Because, for example, if I adopt, for example, site-based welding, uh, in Indian circumstances, I don't see that as working, because we don't have that kind of a skill set where site-based welding is really possible to the required quality. So those are, I mean, you have to look at that. And then the connecting materials and whether it is going to give you that emulative approach that you want to have, the kind of ductility or the demand of ductility that is required from the structure. All those aspects needs to be taken care of. And if you refer to, handbooks like PCI, or maybe there are very good books like Kim Elliott that is available freely if you search on Google, precast structures by Kim Elliott. It will guide you in what are the generally principles of connection designs and so on and so forth.
Hello, sir. This may be question from the future. If we are designing for precast, like building around the core or building around the pods, so are we also doing some demolition plan, or if it is required in future to be demolished or reused or whatever? So are we going with some plan for that sort?
Uh, I mean, you want to use these kind of pods on a temporary structure, right?
Yes, sir, for temporary structure or in case if it requires for demolition or
Yeah,
certain
if we want
adverse
to,
situation.
yeah, if we want to do that, we can easily do that by adopting bolting system for those connecting pods, and then we can take out those pods and reuse it at some other places. For very good example is something like container, which is generally used everywhere as a site office. So I believe Precast India is manufacturing such kind of boxes in precast concrete, which can function as a site office or something like that. So that is very well possible, and you can go multi-story also with that, with a bolted connection. And once your site is over, you can just remove the bolts and load it on trailer and take it to the next site for as a your site office also. Even kind of a temporary your labor residence at the site. If it's a mega project and you need something like 500 laborers or 600 laborers, and you won't have to house them at site, you can use such kind of a system where these 3D rooms can be occupied them as a their residence. And once your project is over, you can move it to your next site. Those kind of things are possible.
Thank you, sir.
Sir was talking about the structure, means the substructure part. What if we can think about how effectively we can use it for retaining walls? Means I've seen about the superstructure part, but how effectively we can use precast for retaining wall construction?
Yeah. See, basically, your question is brilliant, and I liked it, because your majority of the time of substructure actually is going to go into building retaining walls. And if those retaining walls can be made precast, that helps a lot. We have done that on our one of the projects, which is in Bhiwadi, Rajasthan, not Rajasthan, but Haryana, not Bhiwadi, but Sona, where we had this basement construction, and we did a spoon shaped wall which created kind of a hidden columns at the connections, and we grouted those hidden columns to make that work as a stitch concrete joint. And that is how we did it. In our very early project in 2010-11s, we did one building Marvel Sangria, that is in Kondwa in Pune itself, where the retaining wall was done in precast. And the advantage was by the time the raft foundation was over, all our retaining walls were manufactured. And we did, kind of 10 elements per day, and we finished the retaining wall in hardly 1 week or so. So that is the biggest advantage, because retaining wall is something which takes a lot of time, and that can be done in precast.
Okay. Thank you. It was quite interesting and mesmerizing presentation, sir. So we have Uday from Trimble team who will make the presentation. Yeah, Uday, please.
थँक्स सुचिता. हे विसरून चालणार नाही की आपण पुण्यात आहोत, त्यामुळे मी सुरुवात मराठीतून करेन. नमस्कार सर्वांना. मी उदय पंधे. I represent Trimble Solutions India. Direct विषयालाच हात घालू. The topic which I'm going to cover today is digitization of construction. Like, it's the topic of interest for each and everyone in the industry today. There are a lot of products being discussed, there are a lot of technologies being discussed, but how we are different, how we are transforming the digitization process for the entire construction fraternity through different products and processes, that I'm going to demonstrate. So the major product which I'm going to speak about is Tekla 2021. So start with some statistics. Like, when we talk about how our construction projects, how our construction industry is growing and what are the challenges that it has been facing. So 90% of our projects are late. Late because of a lot of rework, late because of a lot of, I should say, issues with the planning and execution. 40% of, like, they go over budget, there is cost overrun. The reason is, there are a lot of reasons basically. 10% of materials are wasted only because of improper planning, logistics planning, execution management, and even the just-in-time or the failure of just-in-time systems. And like 40% of the entire construction, I should say, work, it becomes unproductive. We term it as mula, or waste, in our lean construction or the lean sigma principles. If you see the graph for other industries, like, over the period of time it grows. However, the productivity for the construction has been declining. So it is only because of lack of adoption of new technologies, lack of adoption of new processes and work methodologies in the construction. If that gets implemented, probably there will be a paradigm shift and there will be a significant change in the productivity itself. Peter Drucker said it very rightly. If you can measure it, you can manage it. So that statistic has been a collaborative effort of different surveys, different, I should say, statistical teams which are working across the industry. So I'm going to talk about 3 C's, which is constructible, content enabled, and connected. Like, we are in an era today that, the entire project stakeholders, starting from the client, owners, the contractors, the consultants, different consultants as such. Then we have execution teams, field engineers, and sometimes the consultants are sitting in different geographies. So we have to be connected. So we have to be connected to what? We have to create models which are constructible. If you can create a replica of any physical structure which is constructible without any clashes, without having any rework, so that reduces a lot of time, rework, a lot of productivities are increased. And in the previous session, it was very elaborately mentioned that what needs to be changed, that is the pre-construction processes, so that the standardization can happen, so that the modernization can happen, so that the reworks are minimized, wastages are minimized, and also the faster construction can be achieved. So when we talk about constructible, Tekla provides you the platform flexibility as well as feature enabled product which can help you deliver these constructible models. Constructible म्हणायचं झालं तर automobile sector, if you talk about the automobile sector, they create the prototypes for their models. So these are perfectly designed, perfectly executed smaller pieces or the micro or minor pieces of the final product that gets delivered. construction मध्ये सुद्धा we prepare the kind of 3D models, prototypes and all, but are they really constructible? So with Tekla, you can detail out each and everything that goes into the construction, how it goes into construction, where it goes into the construction, and when it needs to be placed there. Third is content enabled. Like content enabled, when we talk about it, should give information about the geometry. That's very important. It gives information about the uh, quantities. It gives information about the location of it, grade of it, and lot of other materials, embeds, your joint details, your lot of plates or bolts or anything that goes into that. So we have, our design has to be constructible. So if it is constructible, there will be less clashes, and when there are less clashes, then there will be less rework also. So it enriches and it also empowers the people with the data and the resources, as well as the people are connected, they talk seamlessly. So we have platforms which deliver this information from Tekla model to and from to different stakeholders of the project. And the outputs and referrals which are there, these are all content enabled, because every other information that gets shared, it should be linked to some or the other relevant information from that particular project. So it can be located, it can be discussed, reviewed, commented, and executed at all. So when we talk about how Tekla differentiates from some other tools which are there in the market, Tekla is one of the finest tools, the premium product in detailing, and also the BIM processes. So you can see the left-hand side is the model which is created in Tekla. Every other detail that goes into the wall, or maybe it goes into any element of precast project. So these are all detailed out very neatly. There is space, there is feature availability to enhance the detailing to the LOD 500 or even more than that, as compared to the other technologies which are available. So the detail of every particular piece that goes into the construction, which needs to be accounted for, which needs to be costed for and executed for, or even planned for the logistically requirements. So this Tekla particularly gives all the details available. So, so the model is so accurate that you can build from it. Like you don't have to refer any 3D drawings or 2D drawings, or even go to the different sections of it. BIM enabled tool itself gives you the flexibility to view that, visualize it artificially. AR, VR, and other aspects are also associated with it. So when we talk about the connected feature of our product Tekla, so there are different stakeholders, as I mentioned. So the owner, he's responsible for the capital program management. When we talk about the general contractor, is responsible for the project management and quality and schedule, as well as the um, uh, design control sometimes, and engineers who are responsible for the design of the product, as well as the architectural and structural detailing of the same. So when we talk about Tekla, we have collaborative platforms also, through which the data exchange is very seamless. The data exchange gives the audit trail also. So everybody who is sharing, viewing, and editing the data is made responsible and accountable for the delivery, for the data that goes into and comes out. So apart from that, we have I can go to this. So we believe that the greatest challenge in the construction is the lack of quality. It's quality, it's only because of the rework and other unproductive wastages, and coordinated and timely information which is not available. Sometimes most of the times in construction, the information is shared through shared drives or emails. So this particular tool from Trimble enables the data sharing through a single source of truth or single source of information, and it is accessible to everyone across different platforms. Mobility is also available. So Tekla software from Trimble dramatically improves the way the construction business works and collaborates, providing the most complete constructible information management solution also. So when we talk about content enabled, you can create the beautiful concepts for your projects, in no time, or the shortest possible time. You can compare different alternative options, and you can come out with different variance reports in terms of what is the variation in the quantity, what is the variation in the cost, and what would be the time required to execute each of them separately. You can get the quantity takeoff, at a click's time. Like, you can just click the quantity takeoff and the reports are generated. You can even generate your bar bending schedules. You can generate your concrete reports, various other material reports also, including your embeds and other inputs that are going to the construction. So you can even visualize these concepts. You can see these 3D models, and also the timed phased construction sequencing along with that. So you can detail any product project or any structure using this. You can avoid the errors in drawings, because in BIM, if you change any particular element or the property of that element, every other referral drawing also gets changed. So you can manage these changes easily. You don't have to go through or browse through different drawings and different models to change the piece of information that has been revised. So you can standardization has been a very important topic today. So you can also standardize and modernize along with streamlining your work with different agencies and different processes. So this is for infrastructure also. We have tools starting from this is for linear projects, mainly highways, metros, high-speed rails, or you can talk about the semi-high-speed rails and so on. So we have solutions starting from alignment planning, wherein we can come out with various options considering the environmental, geological, as well as the residential and industrial challenges. So it will provide you multiple options to come out with different alignment options. You can select them, you can design them, you can do the project management also, you can do the AR, VR also, and all that design information from the field goes to the equipments, go to the different equipments working on the site, and the design is executed. So even after that, during the O&M phase also, these particular products and informations can be seamlessly integrated with each other. I need video to be played. Yeah. So this. So what I was talking about, BIM to field and then field to BIM again. So the design was created using Tekla structure. It went to the field, it was executed. This is SX10, which is the scanning tool from Trimble side. It is scanning the entire abutment structure. Once it is scanned, it collects the point cloud data, and it compares with the BIM design that has been created using Tekla. This was the design, and that was the point cloud. You can see the variation analysis or variance analysis can be carried out using this tool. So we have a complete cycle of products and suite of products available, which can help you from conceptual modeling till the O&M phase. Yeah, this was the point cloud data, which is overlapped with the design, and you can see the deviations, if any, and this deviation analysis can be carried out. You can skip that now. So I'll move on to the next product in the offering, and like when I talk about this, like 3D model is generally being prepared and it's shared across different stakeholders. However, yeah, yeah. This is done when you are placing the elements, so that you do that. It is done only after the execution, like your abutment is. The difference between what we have designed and what we have placed. Yes, so the design what goes into the field, and from the field it is scanned again to the BIM. So it does the deviation analysis with the field as well as the design. What is in the field and what was designed with the scanning device. Yeah. Just give me. So there is a tool again from Trimble side which does the integrated 4D and 5D BIM. So when we talk about 4D, it's time, and 5D is the cost management. You can create estimates within the tool itself. So when we talk about how BIM helps into, or the BIM is the origin for 4D and 5D. So you have, say, a column structure, you need different cost line items to be created when you are creating a BOQ. So what you need as an input is a labor and material cost, as well as the equipments and machinery is required. And you can even plan the sequencing of each of your zones or your floor plates or your cluster of buildings also. So with this you will be able to achieve the cost reports, quantity reports, your schedule reports, resource reports, and material reports as and when required, as well as the cash flows. So you can also do the tender management briefly with these tools. So this is the possible outcome of the entire integration that happens with the model: cost, quantity, time, or the schedule, and the simulations can be generated using that. So if you talk about the overall life cycle of the project, so we start with different products, starting from the conceptual model till the commissioning and other things. So we have 3D, 4D, and 5D tools, also the field scanning tools. So and this entire suite of products is connected laterally through Trimble Connect, which is a collaborative common data environment from our side. So there are Tekla products which are newly launched in 2020. The earlier ones are discontinued. These are not available today. So we have carbon, graphite, and diamond suite of products from Tekla available on subscription model. So thank you very much for your time.
Yeah, thank you, Uday.